So we're looking at parallel circuits. We have our rules at the top. Voltage rule, the voltage at the battery is going to be the voltage going through each resistor. So if we know that, you got 24 volts going through this one, going through this one, going through this one. The total currents are the sum of all the current going through each individual branch. So going through resistor 1, we're going to call that I1. Going through resistor 2, I2. Going through resistor 3, I3. And anywhere from here, from the start of the battery, before it hits this point right there, all of that, if you see an ammeter there, that is the total current.
Wait, the second circle, did you write something in that?
I2. All right, is this one. I1 would be going through resistor 1, I3 through resistor 3. Now, right here, after the current can go through I1, it can go through R2, R2, R1, R2, and R3 as it comes back through here. Right from this point back towards the battery, if you see an ammeter there, that is also dealing with, all right, the total current, IT. So right here, this would be IT. So these were our three rules. You can use to find the total resistance, sometimes called the equivalent resistance. You can use this. But there is also a second way that I can show this. So the first thing that we're going to take a look at is we're going to start off by making our VIR table. We're going to do it a little bit closer, guys, to this side, just so we have room on the right to do our work. So we're going to write VIR. Okay. How many resistors do we see? 1, 2, and 3. So since we have 3 resistors, we're going to write 1, 2, 3 rows, and then after that, we're going to write T for the total. Okay, we're going to finish our tables here. Cool. Now let's put in our given pieces of information. We know R1 is 6 ohms, so you're going to write that in. R2 is 4 ohms. You're going to write that in. R3 is 12 ohms. You're going to write that in. And when you see a voltmeter, this symbol on a certain diagram, this stands for a voltmeter. All right, if it was across R1, then we would write V1 is 24. But it's across the symbol for the battery, so we're going to write 24 volts here. Now, that is all of our given pieces of information. Now, looking at our rules. If I know all the resistors, I can use this equation to find the total resistance. So I'm just going to show that really quickly so you guys can see that. R1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And I'm going to write it like this. Equals 1 over whatever that's going to come out to be. But let's type in our values. R1 was 6, right? Plus R1 over R2 was 4, plus 1 over R3 is 12. That's going to equal 1 over. Now, a lot of times that's going to be a decimal. There's times where it's not. And so we were going to throw that into our calculator. We're going to throw this into our calculator. So we're going to do 1 divided by 6 plus 1 divided by 4 plus 1 divided by 12. This comes out to be 0.5. So we're going to do, it's got to be 1 divided by 0.5. So 1 divided by that answer. It's going to give us 2 ohms as our total resistance. Now I'm going to just keep that here, and we're going to sit on that for a second because you're going to see there is another way that you can solve it. Okay, so usually how I'm going to go about these ones is, given now these set of rules being a little bit different, if you know the voltage anywhere, they're all the same. So I know 24, all of these are 24, no math needed. So I'm going to write 24, 24, 24, and 24. Okay, cool. So I've got these all good and done. Now what can I do? I can't use the I rule yet because I don't know what any of them are. If you weren't sure on how to use this in your calculator and do this, right, and figure out that it's 2, you can still finish the problem. The rule would be if you know any 2 variables, I call it the rule of 2. If you know any 2 variables in the same row, use the triangle to find the missing piece. So if I want I, if I cover up I in the triangle, that should be V divided by R, but you have to use the specific I row. So I1 would be V1 over R1, 24 over 6, that is 4 amps. I2 is V2 over R2, 24 over 4, that is 6 amps. And I3 is V3 over R3, 24 over 12, which is 2 amps. So I'm going to highlight those because those were things that we had just found. They were not given. And I'm going to input them into their correct spots. I1 was 4. I2 is 6. I3 is 2. All right, so we found those. Now, we don't have 2 variables here, so I can't use the rule of 2. So you're like, all right, crap. Where do I go from here? Well, go back to your rules. We've already used the voltage rule, where they're all equal. All right, again, you could have done this and figured out that this right here is 2, but I'm going to show you how to solve without that. And then if you knew that this was 2, 24 divided by 2 will give you this value here. Or now that I know current, 1, 2, however many there are, if you add up all the currents, that will tell us the total. So I'm going to show that right here. Okay, I'm using this rule. Total current, IT is equal to I1 plus I2 plus I3. So I'm doing 6 plus 4 plus, 4 plus 6 plus 2. I'm doing it in the wrong order. 4 plus 6 plus 2, and that comes out to give me a total of 12 amps. There. Very good. Now I can use my rule of 2 again. Because I have VT and IT, I can solve for RT. VT is, I'm looking for RT. Silly me. VT over IT. VT was 24. IT is 12. Doing this, it comes out to give us 2 ohms. And if you look, using the resistance equation at the top, 1 divided by each of these guys individually, like 1 divided by 6, right? That's 1 over R1, plus 1 over R2 of 1 over 4, plus 1 over R3 of 1 over 12, equals 1 over RT. All right, doing this and hitting equal gave us 0.5. You have to do 1 divided by that number that gets kicked out. Turned out to be 2. All right, here, great. We use these right here, the rules of 2, to figure out these guys, added them all together to get 12, and then did RT is VT over IT using the triangle, and it came out to be 2 as well. Now, if you used this first and got 2 here, you could have figured out IT by doing 24 divided by 2. That would give you the final answer there of 12 amps as well. So this guy here would be 2 ohms.